Welcome back to Earth Science students to another video. We are getting right into our climate unit. Last time we talked about how the tilt of the Earth affects our seasons and our climates. Today we're going to be moving on to ocean currents and how they affect our climates and how they change things depending on where you live in the world. Make sure that you get your assignments done. You have a check for understanding. You have a quiz over last week's topics. And then you're also going to have a check for this video, and that is it for these next 3 days, and they again are all going to be due on Wednesday. Without further ado, let's get right into it. All right, so the first thing we have to talk about is density, because if you imagine in the ocean we have a bunch of water, and mostly they're actually in layers of different varying densities. Okay, so the way that we calculate density is by taking the mass of something divided by its volume. Okay, so mass again is the measure of how much matter is in an object. It's not exactly its weight. Okay, a lot of people say that the weight and the mass are the same thing. Not necessarily, not exactly, because the weight is the force on the mass of an object due to gravity. So instead, mass and weight are very, very different concepts. Okay, mass has to do with the matter in the object. Okay, volume is the space an object takes up. So if you imagine if it's 100 milliliters, that's how much volume that amount of liquid takes up. That's the space that it takes up. And then density is a measure of an object's compactness. So if you imagine things that are really dense are really hard to get through, okay, because all the molecules are really, really compact inside. And then things that are less dense are really easy to go through because the molecules are more spread out and they're not as compact. Okay, so I have a question for you. Which is denser? A brick with a mass of 1 kilogram and a volume of 0.001 meters cubed, or the mass of a wood block, which is 0.5 kilograms, and same volume. Okay, so think about that. Again, think about how you calculate density, where you take the mass divided by the volume, and see if you can figure out which one would have more density, would be more dense. Okay, now I'm going to flip this, and I'm also going to say which is denser in the weightlessness of space. Okay, so if they're in space, think about, does that affect it? Okay, does that affect my density? Okay, hopefully you're thinking to yourself, no, that does not affect the density, because again, like I told you before, weight and mass are not the same thing. Okay, so just because something is weightless, it still has a density, okay, because it still has a mass. So in this case, the thing that has the bigger mass, which in this case is the brick, is going to have the higher density. The molecules in a brick are more tightly and more compact than in the block of wood in this case, even in space. Okay, so normally we do a demo of a density column, and I'm just going to kind of explain what's going to happen here. I'm going to actually post a video of a density column being done along with this video, along with a couple of other videos I want you to watch about ocean currents. But if you took these liquids, I think you guys automatically can pretty much assume these things are not going to mix. Instead of mixing, what's going to happen is if you pour them in the right order, okay, or if you pour them out of order and you wait long enough, they separate. And the more dense liquids are going to be at the bottom. And as you go up, you get different and different densities. So make sure you check out the video of a density column. Normally we do this in class and it's kind of cool because you can see the corn syrup and the honey and the vegetable oil and the water all separated in our column. Okay, next thing I want you to think about, because this goes in part with water as well, which do you think is denser, cold or hot air? And so what you have to think about is which one sinks, because things that are dense tend to sink and things that are less dense tend to rise. Okay, so we've already talked about convection in our class before when we talked about the sun. So which one is denser? Hey, if you answered cold air, you were correct. Okay, cold air sinks to the bottom. Once it warms up, it floats to the top, and then it loses its heat and it becomes more dense and it sinks, excuse me, and then we keep that cycle of convection going. Okay. Now, ocean density varies with different things. So just like air, it varies with temperature. It also varies with its salinity, meaning how much salt is in there. These little machines that I have a picture of here measure the conductivity or the amount of salt in the water, because water accompanied with salt is highly conductive. It conducts electricity very well. And then it also measures the depth. And so real quick, think to yourself, what do you think is going to be denser, the deep ocean water or the surface ocean water? Hey, hopefully you answered that the deep ocean water is going to be more dense than the surface ocean water, obviously because it's below it, right? Because it separates out just like our density columns do. Okay. Now I wanted to show you this graph. I know you can't probably read these numbers here because it's pixelated or whatever, but what we're trying to show here is that this along the left side is the depth in the water. Okay, and we're showing three things: the temperature, the salinity, and the density. Notice that as you go down, okay, okay, a couple things happen. Okay, as you go down in depth, okay, gotta find my cursor. Okay, the temperature, let's see if I can write with my cursor, also goes down. Okay, it's not drastic, but notice that the surface temperature was this hot, okay, and it steadily goes down and it reaches a point that it kind of continues to go down, but a lot less once it hits that certain point of depth. Okay, notice that also that the salinity goes up. Okay, so we have this weird kind of curve here, but then we hit this depth again and we start to get more and more salty. Okay, and then it kind of evens out as you go down even further. Okay, but either way, the important thing is that the salinity, oh my gosh, I cannot write today. Salt salt goes up. Okay, and then you'll notice also on the left or on the right that density goes up as you go down as well. So density's here and it increases as it goes up. So the density this is really bad. I don't have my pen. It's actually broken, so I'm going to see if I can fix it. But either way, the density is actually going up as the depth is going down. Okay, so what makes parts of the ocean denser? Okay, like we said, it has to do with the salinity. More salt means that it's more dense. Okay, and then the temperature also, the colder it is, the more dense it is as well. Okay, This leads us into what we call thermohaline currents. Okay, so two parts to that word. Thermo, talking about its temperature. Haline is another word for salt. Okay, so we're talking about how the temperature and the salinity affects these currents that go all around the world. This bottom picture perfectly shows kind of how ocean water travels throughout the world. And you'll notice that there's a part where it's warm and there's a part where it's cold. And we'll talk about how that affects different places' climates here in a little bit. But let me read here real quick. The ocean stratifies to form layers of different densities. Just like our density column, you can see in this picture that the surface water at the top, and then we have intermediate water, and then we have, as we go down, denser and denser water. And so these things are what fuel our thermohaline circulation. So this difference in density is what causes these currents to come up. Okay, so there's some of it is warm, and then it gets warm, and then it loses its heat, so it goes down and it's dense, and then it warms up again, and then it gets cold again, and it circulates all this water around the entire world. Okay, notice the cold water. Okay, so actually let's say the warm, low nutrients and oxygenated water is the red water. That's the surface water up there. You increase in nutrients as you actually go down because of how much salt they have. Okay, and we'll talk again about that here in a couple of slides when we talk about upwelling. But it's important to know that as the circulation goes, they circulate the salt upward as well to get more nutrient-rich water as well. Okay, so we call this the global ocean conveyor circulation. This shows all the currents that go around the Earth. The red ones are all the warm water, the blue ones are all the cold water, and they get recirculated with deep water, and then warm surface water goes around as well, loses its heat, so then it dives down, and then it gets carried around, and then it eventually warms up and it goes up, and that process continues forever. Okay. Can't find my cursor. There we go. Okay, now this is another video I want you to watch. It explains these currents even further. It's posted below this one in our channel, so make sure that you check it out as well. It's just a YouTube video. It's like a minute and some seconds long, but I really like it, and I think it accurately depicts it in kind of a different way than I have said. Okay, so again, back to why this matters. We're studying climate and how do excuse me, how do these thermohaline currents affect our climate? So what they do is they bring cold water to warm places. Because if you imagine it brings cold water, then it warms up and it rises, and then it continues to travel. It goes to cold places, so it brings warm water to cold places. It cools back down, and so on and so forth. This affects the weather and the climate by distributing heat. Remember that water has a high specific heat. Okay, so it's difficult to change the temperature of the water. So it affects the weather that happens at these different places. Okay, it also distributes salt and nutrients. Remember again that I was talking about upwelling a few slides ago. Basically, the dense cold water that has a lot of salt eventually gets warmed up, and it brings that salt with it, and it brings that nutrient-rich water up to the surface, and that can be very beneficial to certain places on Earth because of the nutrients that it brings to wildlife and to plants and animals and all kinds of stuff. Okay, so another why do we care? Here is an example. If you look on this map, we have Dalhousie, Canada over here on the left. It is at 48 degrees north latitude, And then we have Bergen, Norway, which is at 60 degrees north latitude. Hey, and what I want to know is who do you think has a colder winter? Okay, now most people would say, well, Norway is much farther north. So if you imagine during the winter, like we talked about with the tilt, it gets a lot less sun. So it must be much, much colder than Dalhousie, Canada. When in fact, what actually happens, if you see the blue here, okay, in January, the temperature ranges from 0 to 20 degrees Fahrenheit, whereas in Bergen, it varies between 30 and 40 degrees Fahrenheit. So it's much, much warmer in Bergen than it is in Dalhousie, and that is because of thermohaline circulation. The surface water temperature in Bergen just happens to be in a loop where the water is warm, and Dalhousie is in a loop where the water is extremely cold. Like I said, tilt that we talked about last time is only one factor into determining a place's climate. This is another factor. We would say, based on what we learned last week, that Bergen would get a lot less sun and must be much colder. This is proving that to be a little bit incorrect some of the time. Okay, now after this, we are going to do the density and ocean currents check for understanding. Actually, I'll assign it to you on Thursday, but I do want you to check out this video. It is also posted below, but this is my last slide for you. Hopefully that you guys can get that seasons quiz done, that other check for understanding, and the check for this video. And as always, if you have any questions, please reach out. If you have any trouble with Teams, any technical issues, reach out. And as always, thanks for watching.